So this is a brief outline of what I'll be presenting today. I'll be talking about my inspirations and how I came up with my idea. I'll transition into my investigative question, and I'll talk about how I narrowed down my scope, and I will talk about how I designed my experiment and the results, which I will discuss. So in the past 2 summers, I've had the opportunity to be an intern at a local lab within UW Medicine. And within this lab, they had stringent guidelines on controlling the biohazards that reside within the lab. For example, one must always wear gloves in the lab, and when making stock solution, Bunsen burners and autoclaving technology had to be used to prevent contamination. However, there was one thing that stuck out. The standard beakers, flasks, volumetric tubes, which would hold things like molecular grade water, and experimental solutions were cleaned using standard soap and dishwashing liquid. In addition, the scientists at the lab often used hand sanitizer to cleanse their hands before and after working in the lab. So this led me to my research question: how effective are commercially available cleansing agents at killing bacteria? And regarding to scope, I picked E. coli because it is one of the most studied prokaryotic models, and because it has a wide spectrum of strains, some of which are actually harmful and cause food poisoning, and others of which are useful and help us, like for example, ones that reside in the human gut and help in vitamin absorption. So, in narrowing down the scope of my experiment, I considered 4 distinct cleansing agents. So, I will go into more detail about the 3 I chose later, but briefly, those are Purell hand sanitizer, bleach, antibacterial hand soap, and also bar soap. Bar soap was considered, but ultimately its method of cleansing is so similar to hand soap that it was deemed redundant. And regarding the parameters of my experiment, I considered doing concentration or time, and ultimately I chose concentration because I wanted definitive results, and I felt concentration would give me a better curve. So, in detail, these are the 3 contestants and how they work. So, hand sanitizer is made out of 60% rubbing alcohol, and the rest is mostly water. It's not just diluted to protect our skin. Research has found that bacteria have developed a strong resistance to pure alcohol and actually will expel it. However, bacteria have an affinity for water and thus willingly absorb it along with the alcohol. And the alcohol will dehydrate the cell and often causes it to burst, which results in cell death. Bleach is made out of chloride, which oxidizes basically every key structure in the cell, especially amino acids, which make up the key proteins of the cell. Its concentration is very low in commercial bleach because it's dangerous to the human skin. And lastly, antibacterial hand soap is made out of sodium sulfate, which helps suspend dirty particles in water. But it also has an antibiotic in a low concentration, which is triclosan in this case. And many hand soaps have fragrances as well. So now I'll be talking about how I designed my experiment and the choices I made. So first of all, I mentioned this before. I chose E. coli because it's the most studied prokaryotic model, and so it's a good standard to experiment with. E. coli is a gram-negative bacteria which has a wide spectrum of strains, and most are harmless and can be found in the intestines of many animals, humans included. In contrast, it can also be deadly. In 1983, there was an outbreak of food poisoning in many towns, which was traced back to a strain of E. coli. that can reside in undercooked meats, fruits, and other foods, and is harmful towards humans. And one of the best and easiest ways to safeguard against E. coli is to simply cleanse thoroughly after contact with objects such as raw meats or fruits. So this makes E. coli an ideal target for my cleaning experiment because it's very applicable. So I decided to test my cleaning agents in these concentrations ranging from 3.23% to 25% as measured compared to the volume of the total solution. And so I decided these parameters, I wanted to get a big range so you could see the curve in which the different solutions killed E. coli, but I also wanted to be realistic, which is why my max concentration is 25%. So that gives you about a 1-to-3 ratio between the cleaning agent and the bacteria solution, while the 3.3%, the low, would give you about a 1-to-32